Hello, this video is actually for all of my science classes. This is for term 5. This is for earth science and astronomy. So right now what I'm looking at is an online planetarium. It lets me look at the night sky um, as it would really appear. And so right now it is set to today's date, which at the time I'm recording this is May 28th and 9:50 at night. So have my planetarium pointed at the moon. And today we're talking about lunar phases. Lunar phases are explain why the moon appears to be different shapes at different times of the month. So if I zoom in, you see the moon is a crescent moon right now, a little bit bigger than a crescent moon maybe. And if I'm just gonna go ahead and use this tool here. Ooh. To fast forward a few days. So if I go to the 29th, the moon's a little bit bigger. Hope you can see that. And if I go to the 30th, it moves a little bit. And it gets a little bit bigger still. 31st, a little bit bigger. And I'm going to keep on going until the 5th, which is when our next full moon is. There we go. So June 5th is our next full moon. And actually, there's a partial lunar eclipse on the 5th. And so now it's a full moon. So how does this happen? Well, so today I'm going to give you a link to a lunar eclipse simulator, lunar phase simulator, I'm sorry. You can, if you're using that online planetarium, you can look at how the phase of the moon changes, but this simulator tells you how the phases of the moon change. So quite a few tools here to use. Let me just kind of show you how to use this simulator, because I think it'll really help you on today's practice. So all in the upper right here, this is kind of like the view from Earth. So if you're looking at the moon from Earth, this is what you see. Right now it's pretty dark. The reason it's dark is because, if you look on this diagram on the left, well, right now the moon is between the Earth and the sun. So the sun is over here while the sunlight's coming in. And so if the sun's just lighting up one side of the moon, we don't see any light being reflected off of it. So when it comes to sunlight and things in space, it's all about reflection. The moon and the Earth, for that matter, are kind of like big mirrors. The moon is a really good mirror because it's made of very reflective dust called regolith. And this allows the moon to reflect the sunlight pretty brightly, which gives us nice light to have when we can see the moon at night. But right now, at this time of the month, the Earth can't really see the moon all that well. And actually, this would be during the daytime. You see, this is the day side of the Earth that's facing what's called the new moon phase. The new moon phase just means that the moon is reflecting no light toward the Earth. It's reflecting all the light away from Earth. I can click and drag on the moon and bring it around in its orbit, and I can stop right here, about at the 12 o'clock position. And now I can see that, this looks like half a moon. It's actually called a third quarter. Let me go back to the bottom to make more sense. So let me go to the first quarter. So this is what's being seen from Earth. Again, if we're here on Earth looking at the moon, we can see a first quarter moon. And that's because, well, the moon is, we can see part of the moon's lit side. The lit side is always facing the sun, same for the Earth, but we can only see part of that lit side. If I move the moon all the way over here to be on the far side of the Earth, now that's a full moon. So now, if you're living on the Earth, if you're living on the night side of the Earth, you can see the entire full moon. You can see the entire moon because it's reflecting all of the sun's light. So a few things that might be useful to you guys. There's some diagram options right here. You can click on the show angle if you want to know what the angle is between that. I'm not going to use that. You can show lunar landmark. So on the right side, I see this little purple dot, and on the left side, I see this little purple pole. And so that just kind of shows you, that purple pole shows you the side of the moon that's facing the Earth. And so that purple pole will always face the Earth. And that kind of helps you understand which part of the moon the Earth should be able to see. I can also show time tick marks. And this is useful because I can also turn the Earth. And okay, so right now it's noon on Earth, and I can change it to sunrise. I can change it to midnight. The reason those time tick marks are useful, let me just kind of reset everything here, is there's this blue button down here that says Start Animation, and I can watch the Earth turn and the moon orbit. So I assume they did this so it reflects the actual time it takes to go around the Earth. As you guys will read, it takes a little bit less than a month, and to be exact, 28 days for the moon to go around the Earth one time. And it takes just 1 day for the Earth to go around one time. And so here you can see how the moon changes shape over the course of, a little bit less than a month. And I can change this animation rate to be really slow or a little bit faster if I want to see things go a little bit faster. And if you haven't noticed, on the lower right, there's also something called a horizon diagram. And my astronomy class, you guys will know that this is also called a celestial sphere. The moon and the sun are going across the same path of the sky, just to kind of show you how the sun and the moon move across the celestial sphere. So again, this tool is really useful because you can just pick up and drag the moon and place it between the Earth or away from the Earth to see how that changes what the Earth sees. Remember, when we're talking about what we see here on the Earth, which is shown by this diagram on the right, it's all about how much sunlight is reflected. There's always a day side and a night side to the moon, but depending on where the moon is in its orbit, we cannot see that entire day side or night side. So hope this simulator helps you. You guys have a link to this simulator in the agenda. Lunar phases are really cool, and I hope you guys understand how they work, why we have them. If you have any questions about today's work, let me know. Thanks for stopping by and watching this.